Okay, can you guys see my screen here? Yes? Okay. Can you guys see my screen?
Yeah.
Okay, cool. I don't see the green bars around my screen here. So we're looking at school interface 4, yes?
Yep.
Okay, cool, sorry. Okay, school interface 4, refactoring the school interface class, and then eventually also adding authentication, I think is down here. So kind of just tying up some loose ends, adding, I guess, a new feature, but also kind of cleaning up our code. So let's kind of get to that. So I'm going to go through the motions. Let's fork. Do this quickly. Come on, GitHub. All right, so that's been cloned. That's been forked. I'm gonna clone it now. So we don't want to be in this directory. We want to be in our challenges directory. I have to git clone school interface 4, clone that down, cd into it. Oops, we're gonna school interface 4. And let's bring up a coding window. And VS Code is there. Let's move that to a new desktop and make that larger. All right, so again, our task is pretty clear here. We want to refactor our interface class. So currently we have a runner file. And this is what our school interface kind of looks like, where we just have a while loop, have various cases, and do some logic in there. So again, this works, but again, we've always talked about improving our code. So we're gonna kind of just go through their guidance here and see what they are asking. So in this case, we want to create a class and do all the work there. So kind of bundle everything into the school interface class. So yeah, let's take a look at that. And yeah, it doesn't look like too much work. I'm just moving stuff into a class to get more practice with classes. So let's create a new file and create school interface. What do I want to name this? Let's go snake case interface.py. And then create a class called school interface. It's not going to inherit from anything. And okay, so I'm going to kind of copy code, but probably modify it also. So looks like we're going to create a school instance. Just to kind of use some terminology here. So again, this isn't a case of composition, right? We're not inheriting from a school object. This class is owning a school object. So that is an example of composition. Notice that our current module does not know what school is because we've not imported it. There's no magic way that Python's going to know what we're talking about. So in this case, I'm going to import from classes.school, import school. Because we're using it, we're creating an instance of school and storing that as an instance attribute for the school interface. We need to have access to that school item. Should be from import school. All right, so that's our init method. We're going to pass in the school name. We're going to pass that school name down to our school object and then create a school object as an attribute. And this is an example of composition. We do not need to use inheritance here and probably should not use inheritance here. All right, and then we're going to have a run method. So I'm just going to copy this code. All right, so the run method, we create a school interface instance and we'll call run on it when we actually want to launch the menu. So it looks like we still have our while loop here. That's cool, our inputs and our modes. All right, and then let's take a look at now in runner. We want to simply do something like this. So our runner file is going to import school interface from import school interface, and we're going to use that here. So instead of creating a school object out in the raw, we're going to call it si equals instance of school interface. I'm going to use my high school, which is Huron High School. You guys can use your own high school. Huron High School, and we can get rid of all of this because we basically moved what we had here into our interface. I can just call si.run, and that's my application. So our runner file is very minimal now. All that logic has been moved to school interface. I'm going to launch this and see if it actually works. Python runner 5. Oops, typos are bad. Python runner. There we go. So it looks like our menu is still working. I'm going to trust that this functionality works. Let's just do one. All right, cool. We got our students printed out. I'm going to quit this application because I want to make some more additions. So again, we follow directions here. Program should run each time. Now we have our interface class. Let's see if there's anything in our run method that can be further broken out. Again, this is the whole idea of kind of making more granular or more modular methods. So in this case, instead of having this giant function, there we go. We have this function of run that has all this logic in it. Let's try to break that down so it's actually cleaner and maybe reuse components if we need to. So my first thought here, kind of going away from the README for now, is all these methods or all this logic can be broken into separate methods, right? So instead of just putting all that there, I'm going to create methods here. Again, this is for code organization. This isn't required for functionality, but this is definitely recommended for just making better, easy to read code, something that can be reusable, and something that just is easy to read. So the first one is going to be list all students. So I'll do def list all students. That's going to take in self, because again, these are instance methods. And what's that going to do? That's simply going to call self.schoolListings. Simple enough. Just going to copy that there. Oops. Copy. Paste. All right, so now that I have that method, I'll call that from here, self.list all students. Again, that wasn't a huge gain, right? We just had one line of code. We probably didn't have to, create a method for it, but I just want to make all this consistent. So next, I'm going to create a self.list student by ID, and we're going to pass in an ID, student ID. Or we could have input there. So let's create that method. So def list student by ID. Takes in nothing. We'll grab the inputs here and do all of this good stuff as well. Any thoughts as we kind of reorganize some of our code? So student string, doesn't like that. So that's for tabbing. All right, so we convert, we call school, find student by ID, get that back and print it out. So I think that's all we need to do here. Okay, and all right, so again, our run method is now getting kind of a little more concise, and we're kind of branching this out. So we'll do the same here. This is adding a student, I believe. So self.add new student. Anyone else do anything in their interface class that they want to suggest? Again, while I'm typing all this out, hopefully it won't take too long.
So at least when me and Sean did it, most of the logic was like contained within school, and the interface was basically just like the login panel that then accessed it.
Gotcha. But so I assume you were still getting your inputs from the school interface class, or were you doing that in school also?
No, pretty much what would happen is once the login was like approved, then it would just immediately call the function that would then go into the school's menu and all that stuff. So that way, like, didn't have to constantly reference the school like through several levels.
Like, so you basically, sorry, I guess I'm still trying to picture it. So your school, like, how do you get user input? Was your user input still on the interface level, or was it down in the school class?
It was still like, yeah, done through the same ways before, but it was down in the school class.
Okay, so I see. I guess my only thought there, again, very, very subjective, so there's many ways to do it, would be that, the idea of a school might be separate from interacting with the user. So a school is just an object versus you want to break the interaction or the interface component out separately. So I'd say maybe that would be my reason to keeping input in the school interface class instead of doing that in the school. But again, many ways to go about it. Remove student by ID. Sorry, it's taking prototyping, not really adding functionality right now. Okay.
Ankur, I've got a question on this. So hypothetically, if we have to create something similar to school interface in the future, would you recommend starting how school interface started and start with the lower logic classes and then build up like how they did and then refactor into a menu? or would you recommend starting with the menu and then working down?
Um,
What worked best for you?
That's a good question. I think I would start with the menu just to know what I need. So like I'd create my menu, not have any functionality here, and just like make sure that my options get hit. And then I'll start doing it one by one. So when I need to list all students, I'll probably know I need to create a student class and go through that motion and kind of work downward instead of working from down up, if that makes sense. But again, that's just my preference. I'm not saying one's more right than the other, but I like kind of starting from the user side and saying, all right, how's the user gonna view my application? And then building the functionality from the user's perspective as they're going through the application. Again, that does change. Like when we get into Django and front-end development, usually we start with the back end, as in like the side that's furthest away from the client, and then build our interface from the data. But in this case, yeah, I think I probably start with the menu, but that's just what I'm thinking. All right, so again, I would argue this is cleaner. Again, we have discrete methods. Our run class is much easier to parse. Again, we don't have to see like a 40-line function. It's much more concise here. Let's see what their suggestion was here. Menu class that will show the menu. So this menu, sure, let's do that. Set menu, self, and I guess this will return the node, I believe. Okay, I think that's definitely better core organization. Again, there can be more improvements made here. Looks like menu is in their example, they're just printing out the menu, meaning the input. I don't know. I'm going to go a different route. Again, you guys have control of how you get set your classes, so I'm going to take a different tangent and call this get mode from menu, and that's going to return the mode after querying the user.
One minor thing, this is whenever you in the runner file, whenever you create an instance of school, and then you run, or you make a call to run on that instance.
Yep.
And then in the actual init function, you're making a new another instance of school.
So this is creating a school interface. So the school interface creates a school instance. So again, there's like another layer between before we were creating a school object and calling stuff in the school object directly. Now we have like another layer that's going to own that school object for us. So it's going to create the school object when we create the school interface object. I don't know if that answered your question or if I misunderstood the question. So again, before we were creating a school object and passing name. Again, so it's kind of just a little bit of abstraction, I think, where before we were creating school with the passing the name down. So again, this interface class isn't doing much. It is essentially managing a school object for us instead of us creating a school object. So yeah, instead of creating a school object here, the school interface will do it for us. But the school interface, again, kind of adds additional functionality. In addition to creating a school object, it gives us some ability to create like a UI, kind of all bundled in this one package. That's the whole idea of creating classes, right? Everything's kind of nested in there so that, anyone like Jason, let's say you and I are working on a project. I might have coded up school interface. You don't need to worry about the implementation in that. You just know that what the inputs are and how to interact with it. If I were a great developer, I'd write good documentation. I'm pretty bad about writing documentation for my projects, but that's the whole idea of kind of breaking into pieces. So I can work on one piece, Jason can work on the other piece, and then they can interact with each other once we complete them.
Okay, I see now.
Okay, cool. Yeah, thanks for your
This is
question.
an example of composition, right?
Yes. So again, we talked about inheritance versus composition. This is composition. Again, the composition, use composition when you have has a relationship. So in this case, it's probably not as clear right now, but a school interface has a school that it interacts with. A school interface is not a school, like an instance of a school, right? So like if I had a high school, middle school, elementary school, those would be instances or a type of school, right? So in that case, I would use inheritance because a high school is a type of school versus a school interface is not a type of school. It's something that's associated with school. In this case, it's managing a school object. So when you have a has a relationship, use composition, which just means create attributes and create instances of other objects and store them internally versus inheritance is a relationship where you actually inherit. Like here, you can inherit from school and that would achieve that. Again, if you guys remember way back when last week to the inheritance lecture, if you did use inheritance here, it technically probably will work for you. So in case, instead of doing self.school, you just do self and be able to access all the school methods. So in case I use inheritance, I can just simply do self find student by ID, because that self will know to look in the school class here and then access all these methods and any data that the school happens to have. Again, this can work, but this is not proper design. So inheritance is not the correct answer here. And if you're still kind of confused, about that, definitely review our inheritance lectures. But again, the whole key here is that school interface is not a type of school object. So like a high school, middle school, that's a type of school. School interface is not an actual school. Make sense? Questions about all that? Okay, cool. So again, using composition here. And then, yeah, so I think our interface class looks pretty good. Let's make sure we didn't break any functionality. Python runner, let's add a new student. So let's add student Jason. So we're just talking to Jason. Age, I don't know Jason's age, but we'll guess that he's 24. I don't know if I'm close or way off, who knows. Student ID will be 77.
I'm
Password.
25, so it's pretty close.
All right, one off. Enter student password, let's say donuts will be the password there. And okay, make sure we added the student, so list all students. See if we added them. Yep, so we see Jason, we see his ID, and then let's check our data file, make sure it got written out. Yep, there we go. I guess that's password. Yeah, so we have everything we need here. All right, so it looks like we didn't break functionality with that refactor. Always good to double check. It's easy to really break stuff when you're moving code around. Cool, I think that takes care of part one. So I'm going to say we're victorious. Let's do a git add git commits. Completed refactor. All right, cool. All right, so now the more difficult part, which is adding new functionality, authentication. So if you recall, looking at our data, our staff data and school data, or sorry, students data, they have passwords. We're not using them for anything right now, but we are actually going to use them for authentication. So right now, anyone can run our program, access student records. Obviously, that's not what we want. We don't want anyone to be able to access student records. So let's actually require the user to enter a password. There's some thoughts here. So again, what if the user doesn't exist? What if they get, a bad password? Many things can go wrong. Excuse me. All right, so we want to add an authenticate user on the interface class. So let's start creating that. I think I need some water over here, but def authenticate. So authenticate, that looks wrong. Is that right? I don't know, someone correct me if I mistyped that. Okay. Authenticate user and pass. So looks like we want to call authenticate user before, is that, so above, so before the menu even starts, looks like. So we'll do self.authenticate user, and then we'll get into our menu. So we'll show the menu once they log in successfully. So it looks like authenticate user is going to require something. And they're going to need to try to, let's see. So again, we need to figure out if they successfully authenticate here or not successfully. So I'm going to do valid, or let's call it success. So that's going to be a return value. I'm going to have that be a Boolean. What authenticate user will return true or false based on if they successfully log in. And then if success, get into here. Or actually, the easier way to do it would be if not success, just return. What's going on here? Why is this all grayed out? All right, not sure what VS Code is trying to tell me, but I'll pretend my code's correct because I think it is. All right, so while true, we want to do something.
It knows that your function is not gonna complete, and you
Gotcha.
never get there.
All right, so while true, we're gonna ping the user and ask them to give us input. So enter name, or let's enter ID, and then input, enter password. All right, so we're going to look up the user by ID. Hopefully users are fine with knowing their ID. I don't want to bother with names, but if we want to use name, we could definitely modify our code. So let's get ID equals that, and password equals that. And then we want to make sure that these are valid. So we'll do some check. Let's do this piecemeal. So let's do the print ID password and return true. All right, so I'm going to just again test this out piecemeal.
You need a break.
Yeah, I guess. I mean, in this case, I'm just going to let this go. Python runner. Okay, so we printed out. Looks like we printed out some data somewhere. I'm not sure where that's coming from, but anyway, enter ID. So we'll enter. Let's say we're going to log in as Jason. So Jason ID is 77. Password should be donuts, but let's just type in anything. Green. All right. So again, in this case, we're not authenticating. We're just getting input, and then we return true. So that's kind of simulating that whatever ID and password combination right now, always going to return true. So now we're able to get into our menu. But obviously, we want to verify that these are legit. So let's add a new method. Let's say school.validate credentials. All right, we're going to pass in the ID and password. So again, our school is the one managing all of our students and staff. So that's why we're calling the self.school attribute here, because it's an instance attribute. And we're going to create a new method called validate credentials with the ID and password. If there's any questions, please stop me. Again, if I'm going too fast, definitely want to make sure we don't lose it. All right, so this is going to return some Boolean. So let's say, let's call that success. And if success, we want to return true. Okay, and then we'll handle the non-success case by looping back in here. So that should be fine. Let's maybe put an else in here saying print invalid credentials. All right, so let's implement this, and hopefully we can reuse some of the other methods that already exist. So I'm going to create a new method here at the bottom, just because that's where we are. And we're going to call it validate credentials. So it's going to be a new method, instance method. So we have one instance of the school that has students and staff. So I assume we're only going to let staff log in. I don't know if students need to log in. Sorry, let's read the README. Does anyone remember?
Yeah, you had it. It's just staff.
Okay, thank you. So I guess, yeah, we're only going to search the staff here. We won't let students log in, but maybe we can make that different later. So self.staff is what we're going to iterate over. So I'll do a for s in staff. If s equals s.id equals id. So we have some parameters here, right? We had ID and password that we were passing this way. If that is equal, and if s.password equals password, then we've successfully found what we're looking for, so we'll return true. Those are valid. Else, if we never find it, so again, we need to go through our entire list. Again, I'm just going to say this because again, I've seen some students make this mistake in the past. Don't think you could just do an else and return. Again, I've seen this before. This is kind of not return what you want, because what this is saying is if the first staff member we find doesn't match, then we're just going to say, hey, the staff member doesn't exist. That is not how we want to structure this. We want the for loop to complete entirely. And if it does find something, we're going to return, as in this for loop won't continue. We'll just return because we found the one staff member we're looking for. Otherwise, if we go through this entire staff list and we never hit this return true, we know that return false is what we need to return because we didn't find what we're looking for. Okay, so given that, I think, actually, let's see. We do have a find student by ID. I guess we don't have a find staff by ID, so we could create that, but I'm just gonna kind of leave this as is. Return true, return false. Let's make this clear for staff. All right, you guys with me here? So we pass an ID password, we get a return value. If they successfully logged in, we'll return true from authenticate user because they were able to log in. Otherwise, we'll print invalid credentials and keep looping until they enter something. So let's check out our new implementation here. Okay, don't want to print this out. I want to know where am I printing it out? Looks like
Encore, I think that's in student.py.
Student.py. Thank you. Let's try to find out.
I think it's line 23.
That is very, very helpful. Thank you. All right, so sorry, I get distracted by miscellaneous output. So I'm going to Control C, get that out. Thank you. Thanks, Tanya. All right, so enter ID. So maybe you want to have something a little more descriptive here, but let's enter an ID. Let's try to enter with Jason's ID. So I think that was 77. His password was donuts, but again, keep in mind, Jason was not a staff member, so this should not find someone valid. Oops, we got a bad attribute. That is my fault. So looking at staff, we don't have anything called ID. We have something called employee ID. So that is something that is my goof, but that happens. Life goes on. So we'll do s.employee ID. And then I think password is called password on staff object. So enter ID, let's try 77, password was donuts. All right, it's invalid credentials, because obviously Jason does exist as a student, but we're only searching staff. So we got invalid credentials. That's what we expect. Let's actually enter a valid login. So let's look at, let's go with Mertz. Mertz password is XXX, his ID is 83545. I'm not gonna remember that, so I'm just gonna copy it. Okay, that's ID. Let's enter a bad password to make sure our logic's working. So enter YY, cool. All right, let's actually get it correct. So XX is the password. All right, cool. So that worked. We were able to log in, and now we're able to use our menu. So that's kind of cool. Maybe something else you want to do. Again, we didn't suggest it, but maybe add a logout functionality. So if you want to quit your application entirely, but you want to be able to log out, maybe add that. So you guys are always, obviously you guys are free to add on to what we kind of require. And I hope you guys kind of do, kind of just challenge yourself and see what you can do with your applications. All right, so okay, we are doing most of this correct, but notice that we're gonna keep looping forever. And that's usually not how websites are designed or applications designed, especially when you think of like, if I'm trying to hack into the system, I should not have unlimited attempts to kind of just keep cracking away at this until I hack it, right? So usually most websites have like a number of times you can log in. So I'm actually gonna create a class attribute. Maybe this doesn't need to be a class attribute, but I'm going with it. Failed attempts. You guys, again, anyone can probably make a valid argument that this should be an instance attribute. Like each interface should have its own max failed attempts. I'm just going class attribute because that's what I want, but definitely would not argue against the other way too. All right, so max failed attempts can be hard coded to 5, and then we want to use that here. So attempts will start at 1. No, let's start at 0. All attempts is less than max. Self.max fail attempts. We're going to continue this loop, but once they hit that threshold, as in once we become equal to or greater than that, we're going to cut them off. So if, let's increment attempts, this equals 1. If, I guess we can just print it out here. So we know we're going to get down here if this condition becomes false. So we're going to say print max and then maybe we can automatically quit the user. yeah, so this is what one, I guess, benefit of maybe, oh, how would we do that? Oh, I guess we could just return false, yeah. So try again later, and this will, this return false. So if we return false, we'll get a false up here, and then we'll return. So basically our application will end because the run menu won't get into this part. Okay, that looks cool. Let's change our output a little bit. And let's actually add some nice welcome message. So I'm going to just do that in my run here and say, add like a nice greeter. Let's do self.school.name. Again, this is just optional. I just want to add some nice, nice output. Okay, let's see what things look like now. And I think we're close to done, so hopefully wrap this up. I want to quit, clear. All right, so we had a nice, welcome message. Always nice to see that. Enter ID. Let's go with what we had copied. Like something we want. All right, let's enter some bad IDs. So 6666, password, whatever. Okay, that looks like what I want. Let's keep going. So again, we've done 1 attempt, 2 attempts. This is our 3rd attempt, 4th attempt. All right, this is our 5th attempt. So maybe we should print something saying, hey, this is your last attempt. But hopefully, if we do this one more time incorrectly, we should exit the application automatically. All right, so notice max attempts exhausted, try again later, and we were forced out of the application. So we can't, again, keep hacking at this forever. I guess, obviously we could relaunch the application. We're not that smart about this, but cool. I think that works. So again, this is something, we suggested adding, again, some food for thought, something that you guys hopefully came up with. But this is my solution to that, where we keep track of attempts. We have a hard-coded max attempts. Again, we can make that a little more dynamic if we wanted to. But anyway, we keep track of a counter every time they fail, and then we use that to break out of our loop. Okay, I think that accomplishes it. I don't know if I missed anything. Does anyone have any questions? Any suggestions on adding any features quickly here?
We got one thing. Since you got the self.max failed attempts, can you just do a for loop over the range? That just another idea, because we're just it's just an integer. So
yeah, I like the idea. So we know how many attempts we're gonna have potentially, and this return will break out of it if we ever are successful. So yeah, I like that idea. That's another variation here. So we do for attempts in range self.max fail attempts. So in this case, we don't need this counter. Yeah, I think that's actually maybe a little cleaner. We get rid of some extra variables, delete something I didn't want to. Another way to clean up this code, anytime you have a return statement, anything after that is not going to execute. So I can actually get rid of this else. There's like an implied else here. I usually prefer to have this style. Again, it's not always the easiest to parse, especially if you're not used to it. But in this case, if it ever gets into this if, that's going to hit this, and we're not going to execute anything below this. So again, there's an implied else here, even though I don't have an else written here. I like that style. Again, it's easier for me to read, but you guys do what you guys think is best. I got a column up here. Okay, cool. Thanks for that suggestion, Kevin. Always good to see other implementations there. All right. I think I'm good with this. In fact, one other thing that I don't think we explicitly mentioned, but in your for loop, if you have something that you're not really using, notice that my attempt variable is grayed out. That means I'm not using that variable. You can just use an underscore, which is basically like a placeholder for a value that you're not going to use. This is Python specific, where this is saying I have some value, capture it, but don't capture it in anything. Just this is an empty placeholder for it. But if we did have an attempt in here, maybe we could use that. So let's say print all right, I'm going to wrap this up after this, I promise. So from that instance attribute. And that's going to be an F string. Okay, cool. So now we actually use that attempt value. Sometimes we can tell them how many attempts they have left. So and I guess we probably want to add 1 here. Okay, well, let's try that out and wrap this up then. All right, login attempt 105, sure, that's interesting garbage. All right, attempt 205, garbage. It's actually login with legit stuff, so I forgot the login. 83545. Password's XX. All right, cool, that works. Okay, so that's school interface 4, just adding some additional functionality and refactoring our code. I think that was a good wrap up for school interface. Let's put our application one last time. And I think I'll do the git add commit on my own time. Any questions about school interface? Anything from today? Anything from the past school interface challenges?
Ankur,
Go for it,
I'm
Michael.
sorry. Yeah, I do have a question about line 61. And I'm just curious, this is like an open question, I guess. So in school interface, you are implementing the authenticate user, but you decided to create validate credentials for staff inside of school.
Mhm.
I could see a situation where you could have validate credential inside, like you could have accomplished the same thing inside a school interface, but you decided to push it to school. And I'm just trying to think like, why push it to school versus not have it in school interface, like that whole validation routine. That's what I'm just trying to think through. I don't know if there's like a good reason, or maybe there was a good reason. Like,
Yeah,
I
let's
don't
talk
know.
about
I'm
that.
just thinking out loud.
No, absolutely. I'm glad you asked this question. So Michael is saying, technically we have access to staff here. So we can just do the loop here, right? We don't need to call some method. We have access to staff here. The reason I chose, did I mistype that? No. Sorry, guys. You should call me out on my typos, but yeah, so I think Michael is suggesting or saying that, hey, hypothetically, we could just loop over the staff here. So everything we've done in school, so I could just copy paste. We could do this in here, and yes, that would totally work. Self.school and do everything like this. We could create a separate method for this also in our school interface class, so that wouldn't change too much. The reason I think it's correct, again, sometimes it's subjective, is because since school is the one managing staff, school should be one responsible to interact with staff. So that's the way I think about it. Again, when we talk about like creating classes are data and methods that act upon that data. So everything should be packaged all into one class. In this manner, we're kind of using the data, and again, it is subjective. So I'm not saying it's inherently wrong, but for me, since staff is owned by school, I want to have school do the work for me instead of having that logic baked in here.
Okay, yeah, that makes a lot of sense. And so you're like decoupling the interface from the school.
Sort of, yeah. I mean, if you think about it, again, we don't have this use case, but hypothetically, let's say someone else wanted to validate credentials for a staff. They might not need to create a school interface object if they just want to, let's say in a runner file, instead of creating a school interface, we just create a school object, right? So now that I have a school object, if I wanted to validate credentials, I should be able to do it without having this interface exist. Again, we don't have a use case for this, so it's all kind of just hypothetical at this point. Whatever, I'm not going to give it a great name. So again, now I have the ability to validate. Oh, I don't even have access to school. From classes school, import school. Now I can use it. Validate credentials for staff. So now I could test, if I just want to test, credentials, I could do that outside of interface existing. And to me, that makes sense because again, school has the staff, so it's capable of validating staff without the existence of school interface. And again, think about, as I said, it's subjective. You can make an argument that this logic might be better suited in staff, right? So maybe we have a method here that says def validate login, and we pass in self ID password. And I think, again, this would probably be more proper to kind of, again, break apart that logic. So now I could just return ID equals self dot employee ID and password equals self dot password. So now that I have this method, let's clean up our school a little bit. Instead of doing this, again, since the staff is the one owning that ID or that data, there can be argument that I could just call s dot validate ID password. Again, in this case, I'm not sure if I think we need this method, but again, it's subjective. I've said that probably 5 times now, so I'll stop saying it. But you guys are designers, so again, I've said this before, where any design decision you make, it's not necessarily wrong, but make sure you can back it up, as in make sure you can justify why you did something. And that's the biggest part of, when you're designing something. So don't just put stuff anywhere and say, okay, I just did this because whatever I felt like it. That's not a good reason. But if you can say, all right, I put this method in this class because I believe that, this is better designed for X, Y, and Z reasons, then no one's going to hold it against you. Always leads to good discussions. But okay, that is school interface 4. We're hitting 10:30, so I'm going to wrap this up. But thank you for your questions. Yeah, and hope you guys enjoyed this. Again, definitely study up on it for our assessment.